Mrs. Groves, and I am going to go over section 1.7 notes, which is now taking our functions and representing them as graphs. So, just as a review, we're talking about graphing. And so, the graph, if you're doing a graph of a real world word problem, you would want to have a title. And then you would want to label the input variable with the units and label the output variable with the units. And that's how you would do it if you had a word problem. If you're just graphing, you just have to make sure that you clearly label your x and y axis. So you can use a graph to represent a function. And so a function could be a line like this, and that's the typical function that we are going to be focusing on this semester. In a given table, each corresponding pair of input and output values form an ordered pair. So just as a review, that point right there is represented by an ordered pair. And that is the point. The x-coordinate is the input, and the y-coordinate is the output. The horizontal axis is your x-axis, and the vertical axis is your y-axis. So now let's do an example of graphing a function. So we want to graph this function. And the function that we want to graph is y equals x plus 1. So our first step is we are going to make an input output table. Some of you call it an XY table. All right? And so in this, all right, we now know that our x values come from the domain. So our x value is going to be 1, 2, 3, 4, and 5. Make sure that you clearly label your x and y. And you could write your tables like this, x and y, and do it this way. It doesn't matter. So now you have to find your y values. So you go to this, and for x is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5, and 5 plus 1 is 6. All right. So we have a graph here, and you want to make sure that you clearly label the x and the y, and you are going to plot a point for each ordered pair. Now, sometimes people spend a lot of time with their graphs, and they label each of these points, these numbers. Really, you can simplify your life by just doing 5 and 10. Okay, so this graph goes over here. So then you know that each of these spaces are 1 unit. And so you could have this, you could do something like 2, 4, 6, right? You're just trying to make sure that you're conveying what the units are. So now what you're going to do is you're going to plot these points, 1, 2, 2, 3, 3, 4, 4, 5, and 5, 6. Now, because they gave us these domain values, this is what we really want to be plotting. But if you draw the line, that's okay too. So now we're going to go to the next page. Example number 2. And for example number 2, we're going to learn how to write rules. Okay, we want to write a rule. And our rule will always be y equals something. Now, if you remember back to algebra last year, you might remember this as y equals mx plus b. That's a rule. Okay, and the rules that we're going to be focusing on are rules for lines. So the first step is we're going to make a table. And we're going to take these points and we're going to put them on our table to make it easier for us to determine what the relationship is between x and y. So I have the points 2, 0, 4, 1, 6, 2, 8, 3, and I have 10, 4. So step 2, I've got these. I want to find a relationship between the input and the output. So I'm going to do that in a different color. What is the relationship here? And so the mental work, we know we have to have y equals, and x is going to be on the right-hand side. Now I'm going to give you a little bit of a tip. If we draw this line, and we know we're going to add a number, and we see this line, remember the y-intercept? So we know this number is going to be a negative number. Okay, so it's going to be minus something. So I got to figure out kind of like what I'm going to multiply by my x, and then I'm going to subtract something. All right, and these are all even numbers. So I'm going to say to myself, well, what happens if I take 1/2 of 2? That's going to give me 1. And if I subtract 1, okay, then that is going to give me 0, and it matches. Well, what happens if I take y equals 1/2 of 10? That's going to be 5. Subtract 1. That gives me my 4. And so looking at this, it kind of makes sense. That y-intercept on the graph is -1. And you don't have to worry about that, but you know, between given the table and given this graph, you can come up with your rule. So you're going to write the rule now, and you can write it y equals 1/2 x minus 1 This is also okay. Y equals x divided by 2 minus 1. Okay, so the rule, I rule for the function, we don't have to repeat that, is either this or that. So those are our rules. Now, we want to identify the domain and the range. So when you're doing your homework, it's always good, okay, that you identify the domain. Well, just start it with a D, put a little colon, and x is equal to my x values. 2, 4, 6, 8, and 10. And the range is equal to my y values. 0, 1, 2, 3, and 4. So now what I'd like you to do is you're going to pause the video. You're going to do these problems yourselves. And this problem right here was like our example 1. So for this problem, see example 1. And these two problems, see example number 2. Okay. So take some time, do some practice, make sure you understand these concepts, and bring your questions to class. All right. The first problem. Okay, our function was y equals 1/3 x plus 1. Don't forget you need to label the x and the y. They gave you the domain 0, 3, 6, 9, and 12. You plug these numbers into the function, and that's how you get the 1, 2, 3, and 4, and 5. So for example, for 12, 1/3 of 12 is 4, plus 1 is 5. And this graph was kind of hard to see, but here's how you plot it. And make sure, just keep reminding yourself you have to label the x and the y. And you don't have to draw the line because these are individual points, but if you did, I'm not going to mark that off. So let's see how you did with the rules. And these rules, okay, these problems for the rules, this is, for this standard on functions, this is the exceeds. And so if you are figuring out how to do these, you are doing a great job, right? So we have these points. You come down here, you create your table, and then you look at the relationship between the variables, the points, and you can do some mental work. And if you got the rule as y equals 3x minus 3, great, right? Because if I multiply this by 3, I'm going to get 3 minus 3 is 0. If I take 4 times 3, I'm going to get 12. Minus 3 gives me my 9. And then here is the domain and the range. Okay, and remember, I gave you that little hint, all right? this number right here, -3, is that y-intercept. So you know that this number here, when you're looking at the graph, has to be a negative number. And if you're looking at this graph, you know it has to be a positive number. All right, so that's rules. And we're going to be doing some of those. But there's not going to be a lot of emphasis because this is, for the standards, this is the exceeds. So now this is an important concept. Remember last section, what is a function? A function is a special relation that does not have any repeating x values. Right, so that's a function. And so we're given all these graphs. We want to determine which ones are functions and which ones are not functions. And if we go back to this definition here, and we look at these, and we'll just say this is at 5, and I'm going to draw this vertical line. Okay. And we can see that we've got this vertical line hits our function in 2 places. And we'll call this 5, and we'll call this -5. Actually, to make it simpler, we're just going to call this, so that you can see this, we'll call this 4 and -4. So this ordered pair right here is going to be 5, 4. And this ordered pair right here is going to be 5, -4. So, what does that mean? Well, look at, we have repeating x values. This, I'm going to abbreviate, this is not a function. And I'll abbreviate it NF for this. Okay, that's not a function because we have repeating x values. Now look at these graphs. And draw vertical lines. Are you noticing anything when you draw those vertical lines? Okay. How many places does the function hit that vertical line here? Well, it hits it only once. And it doesn't matter the line, it only hits it once. Here, it hits it once. Here, it hits it once. These are all functions. Now these are not functions. And can you see why? Hint, the vertical line test, which we will abbreviate VLT. Well, look at that. It hits it twice. So we call that failing the vertical line test. The vertical line can only hit our function in one place for it to be a function. Here, it hits it in 3 places. Now you're saying to yourself, well, over here it hits it in 1. Well, you're basically drawing your vertical line to see where it hits the most. Okay? So, to determine if a graph is a function, okay, use VLT. And a vertical line, okay, can only touch the function in one place. So what I want you to do here is draw your vertical lines and determine which ones are functions and which ones are not functions. So pause the video. Okay. And now come back. It hits it twice. So that's not a function. It hits it once. That is a function. Isn't this easy? That hits it once. This is a function. Now, this is an odd one, and this is more of an Algebra 2 concept. I've got my vertical line test, and notice this is a black dot, and this is an open dot. This would be a tricky question. This would be like a bonus problem. So this vertical line only hits in that one spot, because this is an open spot. So this one is a function. Here, hits in 2 places, not a function. Here, hits it in 1 place, that's a function. Isn't this fun? So that's it for section 1.7. Have a good day.